In Math 098, I'm going to finish up section 2, 9.2 here, explaining this concept of finding the inverse. I've already done a problem like this, so maybe you've already practiced this. So I like to just rewrite that f of x is the same thing as y, and then our two-step process is to switch x and y. And maybe even before doing this, I should mention that every linear function that we deal with is one-to-one. The only exception to that is horizontal and vertical lines, because they obviously fail the horizontal line test if it's a horizontal line, and the vertical line test if it's a vertical line. So those are the only types of linear functions that do not have inverses. But for the most part, if I ask you for an inverse, it will exist. So that's my first step. So again, f of x means y, so that's my first step, is to switch x and y. And then my second step is to solve for y. So this two-step process is just subtracting 2 to the left side. And I'm fine if you divide everything by 5 or if you divide each piece by 5. I'm kind of indifferent on if you do. I'll just write them both out. X minus 2 all over 5, or, let's write it this way, x over 5 minus 2 over 5. Now one more thing, so I'm good with either of these answers. I do want you to practice writing this notation though, f inverse of x equals, and then I'll just circle this one. So if you write this answer, just write f inverse of x instead of y equals. And maybe I'll write that as step 3. Rewrite y as f inverse. But there's a couple ways that you can check your work, and I've already shown you a graph. If I pull up a graph, you can already see the last way I showed you. So let's just practice it. Of 5x, I believe it was plus 2. And then, at least if you use my calculator, I have this tool that if I hit alpha x, it makes a fraction for me. So for some of you, you might prefer writing it this way, that x minus 2 all over 5. But the other way does work. So if I look at my two graphs, it looks something like this. But what I need you to notice is that the x's and y's are switching. So on the blue line, 0, 2. On the red line needs to be 2, 0. If I picked out another point, let me go to the table. Like -1, -3 for the blue line needs to become -3, -1 for the red line. I hope you realize how to read a table when you're using a graphing calculator. -1, -3 for the blue curve becomes -3, -1 for the red curve. So -2, -8 for the blue curve needs to become -8. So I have to go all the way up here. -2 for the red curve. And I can find more points that are positive, I think. Like 0, 2, I already mentioned. 2, 0. 1, 7 for the blue curve becomes 7, 1 for the red curve. So that's what you're looking for when you graph on the same axis. I'll go ahead and give you kind of a lame graph right here. So this was one curve, and then this was another curve. So this was f inverse. This is why we like this notation. And one more thing I need to point out for you is they are a reflection over this line, reflected. Sorry if you have a blue-green colorblind, you might not be able to see, reflect over this line, y equals x. And I hope that makes sense to you, because if we flip x and y around, so 0, 2 becomes 2, 0, it needs to be flipped over the line y equals x. So like other points up here need to correspond to points down here. That's why the point of intersection is along that axis. Now the other way to check is what I want you to do with exercise 7. So let me scroll down a little bit. That's doing the composition function. You do the composition function. And it doesn't matter if you do f of f inverse of x or if you do f inverse of f of x. This is the only time that the order doesn't matter for our class. There might be a later time in a different math class where the order doesn't matter for composition. So what that means, I'm just going to do the top one because I'm kind of lazy. If you want to do both, that's up to you. I'm only going to do this one. Is if I do the composition function and I get everything to cancel out and I'm just left with x, then that's how we know. This is our way of checking if they are inverses. So that's why we spent a good chunk of time in section 1 practicing the composition function, because you take the inner function, which is the inverse in this case, x minus 2 over 3, and you're replacing this x minus 2 over 3 in for this x. So what that means is I still have 3 times this replacement plus 2. Well, as I work through this problem, maybe it makes sense, maybe you have a few questions, is instead of distributing this 3 in here, if I'm multiplying by 3 and then later dividing by 3, they're going to cancel each other out. So I'm left with x minus 2 plus 2. Well, I hope when you're looking at that, you look at that and you say, oh, negative 2 plus 2 will cancel each other out, and you're just left with x. And so since we're just left with x, then yes, these are inverses. So that's using algebra. What I just did is using algebra to verify. If you use a graphing calculator, you'd be doing the same thing I did on exercise 6, where you graph both lines. We're looking at 3x plus 2. Well, it's pretty much the same problem that we just did. I didn't even realize that. X minus 2 over 3. And what you'll probably notice as well is that they are inverse operations, like the inverse of addition is subtraction, the inverse of multiplication is division, but the order matters. So that's why I still encourage you to do things the way I'm showing you, because the order matters. For instance, if you just wrote x divided by 3 and then minus 2 over here, you would get the wrong answer. So if we use a table to check our work, what this is showing me is if 3, 11 is on the blue curve, then the ordered pair 11, 3 would be on the red curve. So I need to go down to x is 11, 11, 3. I can go back and look at for different points, like 2, 8 is a point on the blue curve. So 8, 2 must be a point on the red curve. And that's what we're looking for. Let's see another point that might be easy. 0, 2 is a point on the blue curve. 2, 0 is a point on the red curve. So it's just a lot of playing around. That's why a lot of math teachers prefer algebra, because I can actually see the work. There's not a whole lot of work to show with a graph. One more thing before I let you go is if you look at the graph, notice that they are a reflection over the line y equals x. So that might be a good thing for you to write down on a future test. The graph, how about I say the graphs, the two graphs are reflected over y equals x. And there you have it. You should be able to finish the rest of the assignment now if you got stuck anywhere along the way. Yeah, go ahead and get busy. And you have odds, it's about 25 problems, 24 maybe. Make sure you turn it in. So we'll see you.